Welcome back to the stream, anyone tuning in. Over here it's Friday evening, so I'm going to wish you a happy Friday. If it's not currently Friday, I advise you to store it for a future Friday when it may become relevant. This will probably be a fairly quick stream. I know I sometimes say that and then it ends up being like 4 hours anyway, but I've been doing a lot of off-camera work. This week I had less work time than usual because my dad was visiting, which doesn't happen pretty often. It was a really short visit, but anyway, and then I've also been trying to get some 3D prints all fed through the 3D printer and having less of a good time with that than usual. So mostly I think the next step, and the one that I plan to do on this stream, is diagnosing what we can fix with the 3D prints and getting them back on schedule, back on track. But I also took a brief aside to make this strange contraption for the flashing light prize. So maybe in a bit, once the stream is going, I'll demonstrate that live. I made a quick video about it earlier today, but since it's already set up, I thought I might as well show it off live too. So, welcome back to the stream, folks. So, it is Friday, it is evening, but it's still somewhat sunny and warm here. And as you can see, I've been attempting to print this piece and having some problems. For a little context, this is sort of a new version of this piece here for the winch. It's a lot more complicated and significantly larger, and I've been hitting this one particular problem. My printer has two things that really like to fail more than pretty much anything else. I get failed prints because of warping, because this printer doesn't have a heated bed, which is somewhat expected. There's somewhat of a balance between the different factors that can cause warping and the different mitigations. But this is another problem that's actually fairly common with my printer, where something will go wrong with the print geometry elsewhere. This happens more often with models that have, in this case there was really dense infill, and so I ended up with a layer offset right here when the print head, because of extra extrusion in the infill, or because of little boogers that get left on these edges when it makes an overhang, any imperfection in the print can kind of increase the chances that when the print head is accelerating across the surface, it'll kind of drag along that rough surface and then lose steps. And that's just the failure mode when something or other is getting in the way of the print head. If the belt doesn't skip or anything, it just loses stepper motor steps. So that's what you're seeing here. And so there are also other reasons why you might see the stepper motor lose steps. Like, there's a cable that goes bad gradually because of repetitive movement, and so if that was starting to go bad, then you would start to see steps being lost, maybe especially in certain areas of the print that correspond to the bad parts of the cable. But this print, like the ones that I've had fail recently, the offset seems to be due to a geometry feature in the print. You can also see the offsets. Like, this one is a pretty interesting story too. This is an older failed print from the previous spool design. So you can see this rough surface here, which is actually a symptom of the, well, maybe it's not obvious here, but that almost always happens because the print was warping. And so if this side of the print was adhering really well to the print bed, and this side didn't stick as well, and then because of cooling started curling upwards just a little bit, then that extra pressure would have caused over extrusion where there's not really enough room for the amount of plastic that's coming out of the print head, and then that'll just cause kind of this cascading series of kind of additional textures that get added, so the bumpiness kind of magnifies every time you print on top of it. So it's not the greatest. And you can see here that actually was bad enough to cause a layer offset that was right in line with this kind of flat surface that it printed right after a bunch of infill on that warped surface. So James is asking if the current on the driver is high enough. I could certainly turn the current up. I've calibrated that current before, and I mean, yeah, I could turn it up, and that might be one mitigation, but like, this is never the first problem, right? This is always after things have already gotten significantly bad in some other way. So, I mean, if the problem just is that the current isn't high enough, then you can probably turn up the current on the drivers, but it's usually a symptom of something else. And in that case, turning up the current on the drivers wouldn't really necessarily help. We could take a look at that if that seems like the problem. And I mean, I know that the hot end can drag through the freshly laid plastic, but it takes some effort, right? And it's not like the plastic is going to still be molten for any appreciable length of time. It actually takes effort to drag the nozzle through the boogers. So, are we talking about the same thing, James? Oh, you're saying it's not current too low. Okay, I read it the other polarity. But this one, I mean, these are both due to warping. Like, it might not be obvious that the warping was happening, but during the print, it was quite obvious that it was, well, this one was warping. This one actually, it might have been stuff like there's some extra plastic in there. Might have been something like that. Like a little bit of stuff that dripped off the nozzle and then got lodged in the infill. So that could have been it here. Of course, that also might have happened after I stopped the print, I forget. Anyway, those are old. I don't remember as much about what was going on there. These are the newer failures. This one I've already taken the support material off of because it was fun. I think I was showing my dad how the support material worked. But this failed twice. Right there, which corresponds with that first layer of infill. Or that was actually just below that. That top failure matches up with that horizontal, that really big surface fill. This bottom failure, I mean, that might have been around when it was starting that fill. I forget how thick the fills are in this part. You can also see the failures on the grid here misaligning. How many solid top layers do you print, says James. Well, I don't remember what the setting was for this particular print. I'd have to go look at the G-code. And I usually don't think of it in terms of number of layers. It's usually 0.8 millimeters, I think, is the default, but sometimes I use a thicker setting. So I guess usually I print at 0.15 millimeter layers, so you can divide 0.8 by 0.15. Anyway, and then I tried some mitigations. I think one of these, I had an angle that I thought was part of the problem that I changed. Is that this one? This was, I tried printing the other piece, because I think I had the G-code for this handy and I wanted to see if it would work, because I didn't have time to mess with the settings, but I did have time to press print on the one that I already had ready. And this printed for quite a ways just fine. And then right up here, I ended up with an offset right on this same layer. That is interesting. Well, yeah, I mean, I can try turning up the current on those motors. That just, it doesn't seem like something I would need to do, because I set that to the correct value a while ago, and like just changing it now to fix this problem doesn't necessarily seem like the right fix. So let's take off the support material. This is fun, at least. My dad asked me if I ever just print a bunch of support material just to take it apart. Oh, there's the mount for the load cell amplifier. Oh, Tuco's on the rack. I should put the camera on him. Cropping. That looked great when I was looking through the monitor that wasn't cropped. Oh, James is getting ahead of me. They're asking if I could design these parts so they have less support. Well, I mean, that's kind of where I was headed next. I was probably going to change the geometry of the parts rather than just beef up the current on my printer. I mean, you're right. It probably wouldn't hurt to turn up the current a little bit. The main thing I'm worried about is overheating my motors. Although I don't think, if James is implying that it would be trivial to design these parts with much less support, I'm not sure that's the case. I mean, I printed these in the orientation I did for a reason. I wasn't just dumb. I thought about the support, but I also thought about the strength of the part. That was a higher priority. I wonder, man, if I had gotten about this far along with this piece, we would have been able to test the gears. But this is like further along than the other piece, but it doesn't really mount much except for the other end of the spool and the, well, we can mount this. That seems fine. So I thought I was seeing a failure before at this, well, I thought this failure was actually due to this angle at first. But after looking at the way the layers line up, that's not necessarily what happened. It's certainly possible, though. These offsets do actually line up with some of the worst parts of this overhang. But it's a little hard to tell if that was the root cause or not. So I thought that might have been part of the problem, having that overhang with support that wasn't especially dense. So as an experiment, I tried slicing and printing one with much denser support. So that how did that work? Where was the failure here? It was right there. And it was kind of subtle because it was almost parallel to one of these edges. So I got a little bit of an offset down here. And that just seems to be, yeah, that just seems to be lined up with that big flat area again. So maybe my problem is printing flat stuff over support. And this support might just be too thick to even take apart. That might have also been a failure in this experiment. This is the kind that's supposed to just break off in one big chunky piece, though. Oh, that's a little better. Probably use slightly more violent tools if I actually wanted to take this piece apart, but I don't know if I do. Kind of a neat little honeycomb structure inside, though. Oh, that is kind of satisfying once it finally comes apart. It's almost like a weird little mechanized beehive of some sort. So, one thing I might hope to learn from this experiment is whether this crazy dense infill actually supported that overhang any better. So maybe I can try to at least learn that much before I throw this back in the pile of weird PLA hunks. This is so weird. Wow, this is such a strange substance. I wonder if I'd be able to wedge something in between and get it to come apart that way. Spudger. Oh. 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 This is so strange. It's probably even stranger because of the layer offset. That's a pretty neat substance. And it still kind of broke off in an unhelpful way. Yeah, this is still super bad. Really hard to get apart. So I haven't actually tried this in CAD yet, but I'd been thinking about solving this problem, at least in part, by trying to make this self-supporting. And this area in the middle seemed like one of the trickier parts for that, since I actually need this to be sort of a shallow angle so I can access it with pliers, or at least some tool that I can use to tighten the nut when I'm assembling it. But I was thinking about some geometry where it's mostly straight up and down, and then there's like an access notch. And I think that might work out better. Sorry, mouse. Whoa. Ah, this is so strange. Oh, this object is worth having. Oh, Daniel asks if I've played around with Z-hop settings. Not on any of my current printers, no. Haven't needed that since my old MakerBot, but that's an interesting idea. Yeah. Tastes like plastic. That is a weird object. Yeah, this support material is strange. I'm glad I tried it once, but not really useful. I don't think I'm going to bother taking this apart any further. This area around that overhang I was trying to support is just kind of impossible to take apart. So, meh. Interesting failure. What a... ugh. Some of these pieces are nice, and some of them are just uncomfortable. Strange texture. So, yeah. Let's look for geometric solutions. Might go in and tune my printer stepper drivers, but it's a little hard to do that on camera right now. So let's just go to the CAD a bit. Are we lacking in video capture today? James suggests making it accessible with a socket set. Well, that is what I'm doing where I can, but the one I'm talking about, I'll show you why. I am talking about this nut right here. Let me turn off hidden lines to make this a little clearer. So this is the piece we've been printing. I've been thinking about cutting off these edges, these little arms, and printing them separately. It might be a little bit worse for structural, but it'll probably be fine. And it might make the print a little bit easier to do in smaller pieces. But I don't think that's going to be a big impact on printability. It'll just mean that there's less of a big print to fail if it fails. But yeah, I mean, the only alternative I can think of to making this accessible with the motor installed is having it just be a straight hole, Loctiting the nut onto the shaft, and then installing the shaft, installing the motor, putting all the rest of this together, then tightening it from this side. Or, I mean, I could use a bolt instead of a threaded shaft, but these are what I had, and it was nice to use multiples of the same part. I could certainly switch it to the bolt if that makes the design significantly easier, but absent a reason to not use these pieces, they seemed convenient. So maybe that gives you more of an idea of what I'm working with. And then if we're talking about just that piece, let's go to just this printed piece. So some of this stuff could just be taller, like this could drop down, that could drop down, that'd be fine. I still need a cutout for the motor here, but I can add supports on either side of this. Between streams, I added these bolt holes for mounting a bracket that will then attach to the side shells of the winch. So I might want to keep some of that clear. So I might end up wanting to add support tabs like here, here, and over here. And then this can definitely drop down. So I'm going to try modeling that and just see how much I can get away with increasing printability doing that. Let's also remove this. Where did this feature come from? Let's remove this and then add some other accessibility feature to this. So I wonder if we can get it to tell us where this came from. So that's the face we care about. Then edit feature, and it tells us this came from a combination thing here, and then revolve. This is actually what we care about. So we want to go edit the sketch that goes with this revolve. And then, yeah, so then we don't actually want this, but that told us which sketch we care about. Let's go ahead and edit this. This is the one kind of big sketch that I put a bunch of the stuff in this YZ plane into. Let's lock rotation. And maybe go this way. Okay, this is the orientation we've been used to. So I can actually probably just change a lot of this stuff right here. I mean, changing it here means we have to kind of clean up any dependencies that break, but that's good for you. Builds character. And I think I was careful to limit those dependencies. So let's delete that. Add some constraints. That is currently, yeah, not constrained enough. But if I make that vertical, we should be good. That, we actually want that to be, that's supposed to be on that top line. That's better. So, we've got that. This still needs some upness. Then, delete. Delete. And let's give this a little bit of clearance too. Actually, let's not use offset, let's just use a dimension there. So I'm just going to draw some kind of cartoon sketches here, and then add constraints. And then make these collinear so that they sit on the same plane. Alright, and then this was the access notch. Did I even have an angle constraint for that? Oh, I had this. Let's delete this dimension. And then I'm just going to try modifying this to be on this line, and we'll see how that handles the dependency chain. So it's rebuilding and caused a bunch of problems, which is fine. This down here is where we just were on the timeline, so we could actually just go back there and then walk it forward and see what we need to change. This sketch might need updating. Let's go there. Where are we? Sketch 4. So we're in this sketch that has a warning. We can right-click on the sketch and review warning, which sort of tells us where it is. Oh, we lost the sketch plane. Oh, is this trying to sketch cutouts for something? This was on this plane down here where I think we had nuts. I mean, either way, I think we want the plane to be redefined to this bottom plane because that's the only plane we're going to care about now. So let's roll history here. Redefine sketch plane. Now, what if anything was on this sketch? Oh, this is where we're cutting out like a core and then putting the revolved piece back in there. Okay, that's fine. Yeah, so there's the cutout. Then that was supposed to be adding in the revolved piece, but I think we need to edit the revolved piece. This is such a weird quirk of Fusion 360 that I haven't figured out yet. So it's sometimes when you right click on this, edit feature is grayed out, and sometimes it isn't. And I can't tell what causes it. It seems like unselecting it and then reselecting it fixes it. But I don't know what that's about. Okay, so now we've got this base here, and then we've got a support for the bearing. I think that's all we needed here. Alright, so we just merged those two back together. That was kind of unnecessary for that to come out. Maybe I really did want this sketch to be redefined to this plane. Alright, that's looking better. Let's go to the next problem spot. Sketch plane is lost. Similar problem. What are we doing here? Ah, these are bolts. Okay. And I don't think I care whatever those yellow things are. I'm also wondering if I can make this whole thing less wide, because I think the whole thing is too wide. I don't think it needs to be that big. This is where I extrude both of these pieces. Yeah, this is where I just made them out of an extrusion. I think maybe let's try making this less wide if we can. I mean, I ended up adding a bunch of stuff to this. That's gonna cause problems with the side rollers. Okay, let's not do that yet. That's gonna be a huge problem. Let's just go up to this next problem. So what's going on here? So far, things are coming together all right. Oh. Can we go to where this problem is? Oh, pardon me. Thanks, allergies. Well, we don't necessarily need to turn this into the I fuss around with Fusion 360 all day stream, because I can do this off stream and not bore people with it. So this bottom had an okay time printing. This was the problem. And I'm hoping that by reducing the amount of stuff we need to print directly on top of support, we can reduce the problem areas. Yeah, but I still need to do cutouts for these screw areas. Oh, James asks how I sized the spool initially. A spreadsheet and some guesswork. I was trying to figure out how much space, kind of the amount of cord that I expect to use here and then some would take up. So, and I did that by estimating the cord's surface or cross-sectional area when it's wound up and compressed. And I'm expecting the spool to be somewhat oversized from what I actually need, but I would like some headroom there. So yeah, I'm gonna cut this still so that I can access that. And that does lend itself to be a nice shape for the little bracket that goes into this hole to fit into. If I set those a little further in, I can print a support all along that wall and still have the bracket set a little bit into that and meet flush with this base that's printed against the support material. Oh, Flonase. Yeah, I used, actually, yeah. We could talk about allergy stuff, that's a whole separate thing. Anyway, I think I might put this CAD aside for just a sec, because this seems more fun to do off-stream than kind of poking at this frustratedly on a Friday evening. I think maybe this is a good time to do a quick demo of my induction swing, since I've already got that pretty much ready to go. So, that'll be right behind you. So yeah, you might have seen this on a video that I released this afternoon, or maybe you're seeing it for the first time. If so, this is an entry for a very silly contest called the Flashing Light Prize. The goal is to make an incandescent light bulb flash at between 0.5 and 2 hertz. What is James saying? That's where the inductee sits when they're joining your cult. Yes, the induction swing. Exactly. Anyway, It needs a bit of a push to get started, but then it keeps itself going with air power. So up here, there's sort of a weird mechanism with a bit of paper and some pirate duct tape and an airflow regulator. So I've got to go over here and turn this on. And we've got to push. So that's the thing. There might be a few variations we can try, like, I don't know, I tried moving the swing significantly further in its cycle, but this method that I ended up settling on with the compressed air works best with the pendulum not swinging super far. So I can also shut off the air. It'll swing for a little while on its own. Let me give it a push. And you'll also notice that when it's going faster, it has a lot less time over the coil to pick up any energy. So I can compensate for that somewhat by raising the voltage on the transmitter. It also helps to have the coil centered under the receiver. But yeah, it's a surprising amount of energy transfer. Anyway, that might be about it for this stream, unless anybody has questions or suggestions related to this thing. Just thought I'd do something quick for this Friday evening as a bit of a debugging session and progress update on these things. You'll also notice that as the swinging gets less intense, the duty cycle of the flashing gets higher. So I think if I left it long enough, it might just burn out the bulb. This is a 6-volt bulb, and it's probably getting a little bit more than its rated power when it's directly over that receiver. Yeah, none of the parts get super warm, at least not in the modes I've been running it in. Oh, James asks, if you're thinking of making an induction furnace, do you think that same module would be a good starting point? So I haven't done that personally, but I know that's a really popular use for these things. When I was experimenting with this, it's really easy. We could probably cook something on it right now, honestly. I haven't tried heating anything with this coil. We'd have to probably hold something metal kind of a decent distance away from it, and then it would get a little bit warm. The coil it came with was a cylindrical. I can grab it. Yeah, this is the kind of coil those modules usually come with. It's also made from copper tubing. also not in focus. You can see I kind of mangled one end of this, getting it lined up, but with this you can definitely heat metal until it's glowing red in one of these. I wasn't using a powerful enough input power supply to get quite that far, but even just using like a 3 amp 24 volt supply, you can make a screwdriver very, very hot, even if it won't glow red. So yeah, I mean, I got this on Amazon, and you know, the suggested things that you add to your cart are like a graphite crucible and a kilowatt power supply. Although I was hearing from a fellow Twitter.com user at White Cork that they had the same ZVS module, and it worked all right, but definitely didn't run very long at 1 kilowatt, which, yeah, that's not super surprising. The ratings might be a little inflated. Well, thanks for joining this short stream. I forget whether the automatic stream advertisements go out every 45 minutes or whether I changed it. If they're going out every 45 minutes, then maybe we just tweeted a screenshot of this. But that's fine. Tuco is off the rack and I think enjoying a snack over there somewhere. Anyway, thanks for tuning in, and special thanks to my patrons, everybody who sends me hardware and ideas, and people who tune in. Everyone who participates helps a great deal, and I appreciate it. So happy hacking, everyone. I'll see you next time on the next video and on the next stream, and on the next tweet or toot with photos of Tuco.